This video will be about functions in R. Remember that sentence that we have encountered before. Everything in R that exists is an object, and everything that happens is a function call. That means two things. First of all, functions themselves are also objects, meaning they exist somewhere on the computer and we can call them by their name. Secondly, functions are used to do something. Actually, whenever we are doing something in the sense of changing something or applying a certain routine on something, we are effectively calling a function. And that basically means that functions are ubiquitous when it comes to applied data science, but actually when it comes to using R in general. Therefore, understanding what functions are and how we can use them, how we can specify their functioning, is an absolutely essential skill. And it's often these very basic understandings of functions that are the source of more general misunderstandings later on. So what we're about to talk right now is absolute key to understand how you can use R in applied data science. So let's get started. A function is essentially an algorithm which takes a certain input, applies a certain routine on this input, and returns an output. So we can think about this in the following way. You have an input, you pass it to a function routine, you apply the function routine, and you receive an output. Now, there are obviously exceptions. There are also functions that do not take an input. There are also functions who do not produce an output, but the vast majority of functions is working this way. Here's an example. There's a function that is called log. Well, not really surprisingly, this function computes the logarithm of a certain number. So if we apply this graphical idea here, say we take the number 2 as an input, we pass it to the function routine of log. The function log is applying a certain routine on 2, namely computation of the logarithm, and it gives us an output, in this case another number, namely 0.693147, which is the logarithm of 2. As you see here, functions usually have names that we can use to call them. In the uppercase, the name of the function is log, and there are basically two different ways we can call a function by its name, the prefix and the infix form. Now, I'm telling you this to make sense of how we've used functions so far, especially when we used R as a calculator. Because in the vast majority of cases, you do not really need to care about the prefix or infix form way of calling functions, because you will use the prefix form anyway. But I think it's important to take this digression to understand and make sense of how we have used functions so far. So the most common form, as I already said, is the prefix form. Here's an example using the function that we already know, assign. Using a function by the prefix form basically means first to write the name of the function. The name of this function here is assign. So we call the function by writing assign, then open brackets, then pass the so-called arguments of the function within the brackets. These functions usually definitely include the input to the function routine and some other stuff we're talking about later on. In any case, once we've passed all the arguments to the function, we need to close the brackets again. And this in all is a proper prefix form function call that actually calls the function assign and lets it implement its routine by assigning the name test to the object 2. The infix form is particularly well known from mathematical calculations. Here, the idea is that we write the first argument first, then the name of the function, and then the second argument. So 2 plus 3 actually calls the function plus with the arguments 2 and 3. So it's a little bit different than the prefix form. The important thing for you to know is that there is nothing different with functions such as plus or the function assign. Both are standard R functions, and you could actually use the function plus in the prefix form as well. There's no difference. So there's nothing special about mathematical operations such as plus, minus, multiplication, etc. So you don't really need to care how to use the infix form in practice. Just keep in mind that things like multiplication, addition, etc. are normal R functions. And since this is a little bit of a digression that actually mainly applies for mathematical operations, you can have a look at the tutorials and the further readings to delve a little bit deeper into this topic in case you're interested. When it comes to the practical use of functions, you're mainly using the prefix form. And when using the prefix form, you're putting the arguments of the functions within the brackets. And here it's very important to understand that there are usually two types of arguments. First of all, there are mandatory arguments, and secondly, there are optional arguments. Mandatory arguments are arguments that you need to provide for the function to work, and optional arguments are arguments that are not necessary but might be useful. Mandatory arguments usually represent the function input. Like for instance, if you remember the log function, the 2, which we've passed as the first argument to this function, was the typical function input, because the 2 was the subject of the routine of taking the logarithm that then produced the output of the function. Optional arguments usually allow you to specify details on how the function routine should be executed. So there's usually a default option of how the routine is applied. And with some functions, you have certain degrees of freedom of how to tweak this routine to your particular needs. All arguments in functions also have a name, and mandatory arguments usually can be specified via their name. Optional arguments usually must be specified via their name. To better understand what that means, so what's the name of an argument and how we can play with it, let's look at the example of the function mean. As you probably would have guessed, this is a function that computes the mean of a vector. But it's actually a very nice function to illustrate the use of optional and mandatory arguments. So the function mean computes the mean of a vector. So to illustrate how the function mean works, we first need to define a vector. A vector is basically a set of certain elements, and we will define a vector called tvec, and we will just add some arbitrary set of numbers in here. If we define this object, we can refer to it via its name, and we can also pass it to the function mean as an argument. So if we want to call the function mean, we write its name, and you see here in RStudio that you immediately get some suggestions for functions or objects with a certain name when you start typing. So in this case, you just press enter, and you immediately can provide the arguments for the function. So in this case, we want to give as the argument the vector we've defined before. If we execute this call, we then see R computing the mean of the numbers 1, 3, 4, 3, which is 2.75. In this function call, I haven't used the name of the first argument. It wasn't necessary because, as I said, the function mean takes one required argument. And for this required argument, or mandatory argument, we do not need to provide the name because it's a mandatory argument. However, we can do that. When we type mean and we press X, we want to get an overview about the arguments of the function, we can use the tab key. And here we see suggestions for arguments. So we see the first argument to mean is called X. We provide an object as argument by writing X and the equality sign, and then the name of the object or the object itself. So in this case, we would write mean X equals tvec. If we press enter, we see that exactly the same happens as before, and that is because we actually did the very same function call. We just made it explicit that tvec should be used as argument X, which is a required argument. Now you might worry that you haven't known before that the first argument of the function mean is called x, and that's perfectly fine. There's no need to learn all this because there are plenty of options to look it up. First of all, you just write mean, and after opening the brackets, you press the tab key, and RStudio tells you how the arguments are called. Or you use the function help, to which you can pass a function, and you press enter, and down here you will then get a documentation of this function, including its most important arguments and their names. So this is a very handy way to look up how a function actually works, or similarly, you could obviously Google it in the net and then find some explanations of how the function works and how the arguments are called. Now, to illustrate the use of optional arguments, let's define a second vector. Let's call it tvec2. And now, again, let's define a couple of numbers and also add a missing value. A missing value in R is written NA, which stands for not available. And it's used to encode a missing value in the sense that we know that there is an object in that place, but we do not know which one. So for instance, think about that this vector might represent the responses of participants in a study to a certain question. And one of the respondents actually didn't answer the question at all, so you don't know what his or her answer was. Therefore, the answer is missing, and R is encoding this as a missing value or a value that is not available, NA. So if we actually look at this vector down here, we see the NA here as the fifth element of the vector. Now that becomes interesting in our context, because if we now call mean with our new vector tvec2, we might be surprised that the result is NA. And that is because R doesn't know what this fifth value is because it's missing. R doesn't know what the mean of the vector is because the mean of the vector depends on the value of the ultimate element. If NA will later be replaced by 2, the mean will be different as compared to the case where NA actually stands for 8. And therefore, when you compute the mean of a vector with a missing value, the mean will also be a missing value. That might be useful. I think it's a good option because it actually makes you think about why there is a missing value. But sometimes you know that there is a missing value, but you don't care. So for example, you just want to know the mean of the remaining elements. What you would actually need to do is to tell mean that it should filter out all the missing values before computing the actual mean. And you can do that by using an optional argument. So again, we call the function mean on the vector tvec2, and then we now write a comma to now actually add a second argument, which is optional. Again, when we press the tab button, we get some suggestions. And here, the second argument we are using is called NARM. And it accepts two kinds of values, either true or false, depending on whether we actually want to remove missing values before the mean gets calculated or not. So if we set NARM to true, we actually see that the function mean now evaluates to 16.5, which is exactly the mean value of this subset of the vector. Of course, you could also set NARM to false, and thereby to tell mean not to remove missing values before the mean gets calculated. If we execute this, we see that we get exactly the same result as if we had called mean only without specifying the optional argument NARM at all. And this is the basic idea of optional arguments. They always have a default value, and if you do not specify the optional argument, R will proceed with the default value. And the default value for NARM is false. So by default, mean doesn't remove missing values, but returns NA if there is anyone, and any missing value. And I think that's a very wise choice because it makes you think about whether it's a problem that there are missing values or not. And if it's not a problem, you can intentionally set NARM to true and then actually get the mean computed as you wish. So this is basically how function calls work. What the difference between optional and mandatory arguments are. So my suggestion would be that you apply this using the following exercises. And if you feel comfortable with that, it's actually a good idea to move to the next step, namely to define your own functions, which is an incredibly useful concept in practice.